Welcome all in the Dutch Game Garden. Welcome at this talk of Mike and Russell of YoYo Games. They're going to talk about the tool GameMaker, of course, you all know it probably. And Mike is going to talk about his years in the game industry. He's all famous for Lemmings and GTA, so he's going to talk a little bit about that and what he did after that. So first give it up for Russell.
Hi. Hi, can everybody hear me all right? I'm not got any, we decided to opt out of having microphones and things because it's usually much easier to move around and things. So, my name's Russell, I am CTO at YoYo Games, so we're the guys to blame when everything crashes and fails, and you can come and see us about it later, we'll be taking bug reports. So, okay, so a little bit about YoYo Games to start off with. I'm actually going to bore you a little bit later on about my experience with Lemmings as well, because Mike and I worked on it together. So we've been around for quite some time. So that's a little bit about the YoYo management team. Mark Overmars, I'm sure a lot of you can know, he originated it's kind of GameMaker. It's kind of, we run it now on a day-to-day basis. So Sandy is the CEO at YoYo. I'm CTO, that means I get to do the technical stuff and have fun. Mike is head of development, so we blame him for all the bugs. And Stuart, who's sitting with us as well, he is head of production and partnerships, so he's the one to talk to if you want any partnership with us. So GameMaker, I'm sure you all know it, and we've got to educate some groups as to what GameMaker actually is. Here's just some of the games which people know. Which are actually made in GameMaker. We are constantly amazed and surprised at the creativity of others using GameMaker. It's fantastic. My own background, I came from AAA. It's kind of games, not just doing Lemmings. I also worked on Medal of Honor. I worked on Formula 1 games. I did Harry Potter Quidditch, Grand Theft Auto on PlayStation, that sort of thing. So I came to GameMaker as a complete newbie. Had no idea what it was actually like. This was 5 years ago now, and have just been amazed at the creativity of others using GameMaker. Some little stats about GameMaker. The free version downloads at least 3,000 times a day. That was a surprise to us. Our conversion rate there, actually turning that into sales, is a little bit less than that. Unfortunately, we'd like it to be that high. So we've had more than 5 million downloads of all versions since 2007, which is when YoYo took over GameMaker at that point. So its kind of current run rate is around about 1.5 million a year. I'm not just going to read the slides. So, and most of these figures can speak for themselves. We have an entry-level version which is free, but has some limitations on Studio. Our entry one, the standard, is $50. $99 gets you professional, which we still think is great value for it's kind of what we're actually giving. You want everything, which is all exporters, free updates, and all the rest of it. It's $800 for Master. So enough of the sales pitch there. A little bit of history. GameMaker Studio. GameMaker is 15 years old, right? This year. I mean, that's amazing. The last version of just GameMaker was 8.1, which released in 2010. That was the first one that Mike and I kind of worked on together. We only used to create Windows executables, right? That's kind of GameMaker's heritage. We do have one that we don't talk about very often, GameMaker for Mac, that actually does produce Mac executables as well. That was my first job when I first joined YoYo, was to get GameMaker for Mac out the door. So you can blame me for that one. We actually started working on GameMaker. The original target for when Mike and I joined, one of the reasons that we joined, was that we were doing a PSP version of GameMaker. So we had it all working with it's kind of PSP, the original Sony PSP, and we actually launched a couple of games. It's kind of using the PSP as well. But really, Sony weren't ready for that type of game on its kind of PSP. We didn't actually make public any of those targets, and the technology behind Studio we had actually been working on, and part of the initial push that we had was that we were taking games that our community had developed using GameMaker and taking them to other platforms. So the first version we went into public with that was in any way studio was HTML5. We wrote a compiler that takes GML language and actually turns it into JavaScript directly, and then runs that within the browser. And that was about 3 years ago now that we did that. So we've had a good long run with HTML5 ever since then. We then added, 2 years ago now, in fact it was our second birthday last Thursday, was GameMaker Studio was launched, and we added iOS and Android HTML5, Windows and Mac at that time. Okay, so that's what we actually launched with. And this year we are just preparing and finishing off all of our it's a range of console exports as well. So I'll touch on that again in a minute. So GameMaker Studio, if you're not familiar with it, it is split into 4 sections. We have our Maker, which is the IDE, which is the familiar part that people will know, love and or hate. But that's the Maker side of things. There's the Asset Packager, which is something new that we added, which basically packages all the assets up, converts it into something that the target devices can actually use, and it puts it all together and does the compilation part of it. Then we have the runner and what we call the YoYo compiler. So the runner and YoYo compiler are basically the same thing. It's the runtime end of it's how GameMaker Studio runs. The YoYo compiler is a way of the YoYo compiler basically turns everything from GML into C++, and then we compile it using the target compiler. So it's all running native at that point, and then you can run it on your actual device. So if again we do a little bit of education time. So what is GameMaker Studio? I'm going to show you a little bit later on, but you can create assets, sprites, backgrounds, sounds, rooms, paths, timelines. We also now support importing Flash assets, so you can import Flash graphical assets in SWFs. You can also import Spine files now. We have the full Spine runtime in there, including the freeform deformation, which has just been added to Spine. And last year we added shaders. You can write both vertex and pixel shaders now using GameMaker Studio, and it's going to get them working directly. So objects really tile those assets together and add game logic. So you can either write in drag and drop, or you can write in GML, which is the GameMaker language. Now, contrary to popular belief, we are not getting rid of drag and drop. Drag and drop is here to stay. There hasn't been much in the way of changes in drag and drop recently, because it's actually quite hard for us to make changes at that level. That's going to change, it's going to fairly soon, but we are not getting rid of any drag and drop. GML, it's easier for us to work with just now, so most of the new things come to GML. We will be reflecting these changes across the drag and drop as well. We're also doing a lot more with extensions now. Coming soon, we have a marketplace where you will be able to share extensions. You will be able to share, we've opened extensions up so that they include assets, so that you can actually have extensions that are just sprites. You can have backgrounds, you can have sounds, rooms, paths, timelines, everything that you can do as an asset, you can now put into an extension. And then you'll be able to share and sell, if you wish, within the marketplace. You don't have to sell, you can do it for free as well. So it depends on what you actually want to do there. So it's very easy to make games within GameMaker. On the IDE, yes, currently it runs on Windows Desktop. We're kind of constrained by the technology GameMaker's written in. The IDE is written in Delphi. It's getting a bit long in the tooth now. We do have a project underway to rewrite the Maker side of things, which will become another sort of GameMaker Studio 2.0 in the future. But that's a little bit away at the moment. We can create and manage projects within the IDE. We have various things, an image editor, a room editor, the code editor side of things. You actually create things inside here. We do the drag and drop there, build extensions. Basically, you interact directly with your project. And recently, we have added a source level debugger. It's one of the big things in GameMaker was that there was no easy way to debug at a line-by-line level. There was a debugger, but it was frame to frame, so that you could stop it on a particular frame and examine what was happening, but you couldn't really see what was happening with particular events and how they were interacting and what was going on with objects. We have now added a source level debugger. In fact, we've already expanded that since we released it, and you can now do profiling within there. You can get an idea of how fast your code is actually running. You can see how things are, it's going to run relatively. We're gradually adding that functionality, allowing you to look at different types. So you can look at lists, maps, you can look at all the various types within GameMaker. Soon you'll be able to look at textures, surfaces, what is happening with the actual it's kind of draw calls and things like that that's going on. So we're gradually adding much more functionality within the debugger side of things, allowing you to see what's happening within your code. On the asset packager, what is it that actually doing? Basically, this is a standalone compiler that takes projects and turns them into a game file, which will be read by the actual it's going to run on the target device. It puts it into a target-ready format, so that the runner on the device can actually run as fast as possible. It takes all your assets, no matter what they are, sprites, backgrounds, whether they're tiles, fonts, and will convert them into textures and allow you to group them together as texture atlases, or as we call them, texture pages. We'll also convert your audio into target formats you will actually be able to play on the device. And we'll handle all that conversion for you, though you do have control over things like bit rates and frequency, playback, how many channels it actually has, and whether it's going to be used for 3D. We will actually take all drag and drop now is converted into GML. It's kind of in previous versions of GameMaker, it was run as a sort of separate executable step interspersed with the GML. But now we convert everything to GML so that compilation and optimization can happen once, and then it can all run as fast as possible. Just as an example, just raw Studio runs at between 5 and 10 times faster than 8.1. Okay, with YoYo Compiler, you can actually take that up to 100 times faster on the CPU. A lot of games these days are actually GPU limited, but they're not CPU limited. Okay, so you really have to, that's one of the reasons for having the profilers, so let you understand a little bit more about what's actually going on within your game. So normally we compile the GML into a virtual machine, or if you're using the YoYo compiler, we convert it into C++, and then, or in the HTML5, we're converting it directly to JavaScript, and it's executed from there. So the actual runner itself, it loads those files the asset compiler has created. The virtual machine runs interpreted code. Now this is important for various scenarios where it's kind of things are to be sandboxed, and that's kind of something that could be more important in the future. The runner is either written in C++ or JavaScript. We actually share about 85 to 90% of the code of the runner is actually shared across all targets. Okay, we actually only have a very small layer which needs to be rewritten when we go from target to target, which is one of the reasons why we've got so many targets, is because it's relatively simple for us to actually move to something which is different. It provides the framework and all the runtime libraries on which the whole GameMaker system runs. And yes, we do sandbox it. There are several reasons for this. The biggest problem we find as people take games between different platforms is that they all expect it to be Windows. They all expect it to work the same way, when most of these target devices don't work the same way. You have limited file access, you have limited access to resources, you have limited network access, you can't do all these things. Most devices are sandboxed in some way. We took the decision to impose that on our Windows users as well. Now, the extension mechanism is there, in which you can then use if you need to get around that. It's kind of a particular thing. But we unapologetically impose these on our Windows users so that people don't get used to this fact that they can do anything on their Windows and then complain to us because as soon as they come to iOS, Android, Tizen, HTML5, why can't I do all these fantastic things that I can do under the Windows desktop? we're trying to educate people to a certain extent as to what the limitations are on other devices. Windows is not the be-all and end-all, and macOS has different sandboxing rules associated with that, particularly with their store. We don't give any native access from interpreted code as well. That's quite an important thing, particularly as we come towards consoles and things like that, where platform holders are much more focused on security issues that could be introduced from game engines. And a runner can be signed and could be downloaded from other stores as well. And it's the same runner across all games, so that we can test. So the YoYo compiler, it does basically create C++ code at the end of the day. We use the target compiler on the device. This was a particular design decision when we created the YoYo compiler. The original plan was to use LLVM as a back end and use the optimizer and things like that there. When we started looking at the next-gen consoles and various other platforms, which we are still to target, then we realized that it was going to be much more flexible if we took a C++ step to start off with and then targeted the actual device, because access to the C++ compiler is generally much more acceptable than trying to write directly to ELF code or to its kind of code internally in memory. That there's some more security permissions and things like that involved in doing those things. So we can also then link with third-party libraries and things like that at that point as well. So it was a much better option for us in terms of where we're looking to go in the future. Of course, YoYo compiler, that does also mean that YoYo compiler relies on the fact that we've got the C++ compiler there that's generally only available for licensed developers on those particular platforms. So one of the reasons why we also keep the sandboxed this kind of thing as well, so that we can support more. So where are we just now? This is a kind of snapshot, roughly, of where we are just now with target devices. So we cover web, desktop, mobile, and console now. Some of these boxes around the outside may be unannounced just yet, but I shouldn't have stolen Sandy's slide, should I? Most of these are available now, either directly from platform holders themselves. There's actually one missing here, which is PS3, and on the console side of things. And you can either have them as part of Master Collection, or if you are a developer on those platforms, then come and talk to us. Okay, this is where I insert demo here. So I'm going to just move across to my Windows 8 machine, which happens to be exactly the same machine. So I was hoping to show you the Vita and things like that here, but unfortunately the device driver is not working, so I can't show you that just yet. This is a game that we put together. In fact, it was put together by one programmer and one artist over 2 days. Okay, it was done for GDC 2 years ago? 2013, yeah. Okay, so last year. It's fairly simple. GameMaker, this is your familiar resource tree here on the left, sprites. We have a full sprite editor built in. So we added analytics to GameMaker. We were actually quite surprised to discover that the image editor is used as much as it actually is, which it kind of means it's been getting a little bit more love recently, but it's quite a surprise. We've got the sounds built in now. You can change sample rate. You can change how many channels it actually has, the bit depth of that, or if it's going to be converted to compressed format. We now use OGG as all our compressed formats on target devices, on native. On HTML5, we still have to convert to MP3 or OGG, because not all browsers handle it's got one format. We have plans in the future to add more sound features. We're going to allow layered sounds and things like that, and more designer input to how sounds are actually played back. That'll be across the next few months. You can have scripts, our fonts. I'm sure most of you are very familiar with all these things here. So objects tie everything together. It's one of the things which we added recently is that all these editors can now pop out. This particular version is 1.2, and they're not doing that, but the most recent version we actually changed how all the window control works within GameMaker. So GameMaker Studio, pretty much the same as all other versions of GameMaker except for this target drop-down, which means that we can choose which target one we've got. So this is Master Collection here, so this has Windows, Mac OS X, HTML5, iOS, Android, Windows 8 JavaScript or native, Windows Phone 8, Ubuntu, Tizen, various flavors, Windows, and the YYC is YoYo compiler there. So we'll just choose Windows to start off with. Once it's kind of building a game, there we go. This compilation process, it can take a little bit of time the first time. It caches things in between. So Angry Cat Spaced, that's it. We have built-in Box 2D physics, and there you go. As I say, it was one programmer, one artist, 2 days. Across here now. The beauty of GameMaker Studio, of course, is that once we've got our version working under Windows, we can just choose one of the other types. I'll just choose HTML5. Now we go across. This is probably going to error because I'm running inside a virtual machine, but I'm just going to drop across to, there you go, some obscure setting that's got here, and I just happen to know that it's on that particular URL. So, unfortunately, resolution of this display isn't ideal. So here we go, there we are. And it works exactly the same way, with no code changes whatsoever. If I had all the other devices set up properly with device drivers and everything installed correctly, it works exactly the same way whether you're targeting kind of Windows or HTML5. I was hoping to show you exactly the same thing running on Vita, similarly on Android, etc. It really is that simple to actually go and do. We look to make game creation as easy as possible, so that it's as open as possible, so you can use the time to actually be creative in what you're actually doing and not having to be thinking about what technology do you need to actually go away and do these things. We're always open to ideas. The product is constantly updated. We've been adding targets for the last 2 years. We now support 14 targets in total, and we're open to talking about more. We're also open to talking about various features that people may want, or that may already be in there and you don't actually know about, and it's a good point. So you could, it's going to come and speak to us afterwards. Does anybody have any questions just now? We don't have, oh, yeah.
Yeah, can you say something about source control or teamwork in GameMaker?
Yes, we have built in SVN features. Now, we have been criticised quite a bit about SVN features. One of the major things that we did on Studio, I should say, is GameMaker itself used to have just a single file format that was everything for a project. Now that causes problems because it's not good for source control, and also meant if that file format got corrupted in some way, you could lose the whole project easily. Now we changed that so that GameMaker Studio now works on a directory structure. It's all text files except for the actual assets themselves. So pictures are PNGs, and audio is the source format that you've actually given us. They're all stored within the project directory structure, and all files are stored as XML. So they're all easily put into source control yourself. We have Svn integration. Our problem is that all SVNs are not the same, and they're all slightly different from each other, and people have different setups for different things, and it's been a bit of a nightmare for us. It works for us, it works for what we're actually doing. We're trying to improve that across time. We also have plans to integrate Git as well across, because we're finding more and more of our customers are using Git. But we do support source control Whether at the one level is the project is easily source controlled because you can just put that into Tortoise, or you can put it into Tortoise Git, or using Mercurial if you want, or you can use the built-in, and if it works for you, great. If it doesn't work, let us know and work with us on actually kind of getting it fixed. But yes, we do actually have Eskin source control in there. And yes, we have been criticised for it. You take that one on the chin.
Thanks.
Okay. Anything else? There'll be an opportunity afterwards to come up and bash our ears. Right, I'm going to hand over to Mike now for the main meat of the actual talk. And then I'll come back and bore you about the PC Lemmings.
Okay. So when I was going to come over here, it was suggested I do a talk about me, which was a bit unusual, but on you go. So I'm going to talk about my early career when we did Lemmings and then a little bit of GTA. I'm not going to do it all because it would take forever, so I'll do the interesting bits. So I started programming in 1983 when I was 13. I got one of these that a lot of you will never have seen before. A wonderful 1K of RAM. And you got this little RAM pack on the back that boosted it up to a humongous 16K. It had a terrible keyboard, and you would wait 20 minutes for anything to load at all. You would sit in programming basic. If you wanted to save it, 20 minutes. You were trying to load an assembler or something to do something, 20 minutes. In fact, when I first started, I had an assembler, then a debugger to load in. So it was 40 minutes. I'd write a couple lines of code, the whole thing would crash, and I'd have to do it all again. So terrible machines, but it got me going, and it was very cheap at the time. What actually changed for me was I was writing in BASIC because I was 13, and that's all I had. I had a book, a couple of magazines would come out, and I get that. And then all of a sudden, I got a magazine with this listing in it, and it had the usual bits of BASIC in it, but what it also had was a full listing of assembler. Now, the back of the manual for ZX81, which none of you would have seen because it's a million years old now, it had all these hex numbers down the side and things on the left. I had no idea what they were. It was all kind of magic. And then all of a sudden, this came out, and it had a full assembly program. You can just see it down there, with the hex down the other side. And all of a sudden, I could relate what those numbers meant to the other program. And over at this bit, using my magic pointer, you see a little thing called border. There's a little loop there, and that drew a border around the screen. And all of a sudden, I could suddenly see if I changed this, that happened. And I was able to start getting into assembler really early on. And all the kind of games back in those days did assembler, because BASIC was just way too slow. So I was able to start getting really familiar with a machine at a very early age, which was great. My ZX81 then died, as these horrible little machines do, and I was left without a computer for about a year, which was torture. I ended up just writing programs on bits of paper to keep my interest. I then ended up doing Spectrum work for, my mum actually worked in a lawyer's office, and they were interested in getting a database of all the clients that they had. Now, they had a big old-fashioned computer, and it was massive. It was probably from the wall to here, and it had big 8-inch floppies, they were about this size. So when I'd said I could do one of these things, and it was just going to be a little machine, they were quite interested. So I went and wrote a database for them, and they got me a really fancy setup for the time. Normally, Spectrum users had a ZX Spectrum and a tape recorder, and that was it. I ended up getting that big fancy keyboard down there, and a floppy drive for it, and it was just the most expensive setup I'd ever seen for a Spectrum user. I did them a database, but I was able to hold on to the machine for about a year because they just weren't ready for it. I then took it into them, set it up, and showed them how to use it. Back in those days, this would have been about 85, so it was like 15. They had a system where it was basically a roll of cards with a number on it and then all the user's information. And that's how they did all the lookups. They would get the person's name, look it up, type the number into the computer, and get their information. Because of Spectrum Basic, it had lovely string searching features. So they could just type in a name and I would just list them, and they thought this was amazing. and that I was a genius. But Spectrum Basic did all the work for me. It's great. So once that went into my mum's office, again, I was left without a machine. In the meantime, while I had this, I was able to play further with interesting things, because a database doesn't take very long to write. It took me a few weeks, really. So I had this machine for a year just playing with stuff. There was loads of cool magazines that came out back in these days, stacks and stacks of them. This was one of my favorites. It was basically a ROM listing of the ZX Spectrum. But these numbers over here, magic pointer, show you values to put in throughout the code that sped it up. So this is the ROM load and save routines. Now, on the Spectrum, they had turbo loaders because it loaded in at 1500 baud, which it took quite a while, 10 minutes or so to load a game. Whereas this, you could double the speed of it, up to 3000 baud was the standard one. But it had a whole load of numbers down there for actually playing. And you could go and just type this into an assembler and then change all these numbers and make your own turbo loader. It was really good fun. I actually got one up to 6000 baud from a normal tape recorder, which was the same as the ZX microdrive, but it only worked on my tape recorder, so nobody else could do it. But it was really cool. So after that computer went in, I got asked what I wanted for my Christmas. And it actually says a Mattel Aquarius, which is an unknown computer and a load of rubbish. Fortunately, about 3 weeks before Christmas, I saw this one. And my mum hadn't bought the other one yet, so I was able to get this, which was the Commodore Plus 4. Now, it's kind of an unremarkable machine from Commodore, but it had a couple of great assets for it. One was it had a really good BASIC in it. The other, it introduced me to 6502, which was its main assembly language. The ZX81 and the Spectrum both used Z80, so it was a bit of a shift for me, and it took a bit of getting used to. But it also had a built-in monitor, so you could press the button and jump in, and you could see games, programs, and actually go in and play with them. It had a line assembler, which is a slightly strange concept, which means you could go into the debugger, list a bit of assembler, and then type one line in and hit enter, and it would put that line in straight into memory. Now, normally in assemblers, you would have a text file, you would edit it, you'd write lots of lines, you'd hit assemble, and off it go. With a line assembler, you're doing one line at a time directly into memory, which means if you ever had to add a line in, you had to block copy the whole bit of memory down, and then go and fix up all the calls and jump routines everywhere. But I actually had an assembler and hated it, so I wrote this game down here completely in the line assembler, and I had a pad full of all the routines that I had to go and fix every time I moved a bit of code. Which was a bit mad, but it was relatively enjoyable. So I did that one in about 1987. The actual URL you can see down there. You can go and play it if you really want to. It's really bad. It actually got, when I was doing this, I made a character editor for it to redefine my character set. And it actually got published. So that was my first published thing in May 1987, that blurb says. And that was great. First published article, fantastic. Bunch of numbers that went in. I got £60 for that, which was fantastic. I was overjoyed. What really annoyed me was they didn't put my name in the article, so I couldn't show anybody. Everybody else is in the magazine. I did. So never mind. But there you go. So that was my first thing published and got me on my way. After that, I bought a Commodore 64. Well, I say I bought. My mother bought for me again. Commodore 64 from my friend who was getting rid of his. And that really set me on my kind of career path. Commodore 64 is a great machine. I don't know if you've played any of the old emulator stuff on it. You get direct access to the hardware. It's 6502, I was able to go straight over. A lot of the hardware was similar for its scrolling and character maps, so I was very familiar with it. But it also introduced me to hardware sprites, which the 64 meant it could do really good shoot 'em up games and all that kind of stuff. So in the intervening time, from about 84 onwards, I was actually going to a computer club with Russel, Dave Jones, and another guy called Steve Hammond, and we would kind of form the DMA Design later on. The Commodore 64 is what really got me into it, into DMA, and we did, my first game was a game called Ballistics, which was a port of an Atari ST game, which then went onto the Amiga as well. The Commodore 64 port was really bad, but it worked. So that was my first thing. Dave managed to get a contract for that and got us in. So that's our first office. Just this red bit at the top here. There's a big long staircase up there and just 2 rooms. Big one at the front and a smallish one at the back. All the development was really in the front office. The back was more business stuff. There was Russell was still at university at that point. So there was myself, I was the first employee at DMA, and then Dave, who was running it. The guy in the window there, a guy called Gary Timmins, he did all the art and the animations for Lemmings. And he came along a month or so after we'd opened the office. We'd actually been working for about 3 months before we got the office, doing ballistics and other things in his bedroom. A real high-tech environment where we had a desk and a chest of drawers with a board stuck in it with a computer on it, so we'd stagger out of it. Very high-tech. So there's us in the early days. I'm stunning. Yes. That's me writing Blood Money on the Commodore 64. At this time I had a PC that squirted the code down to Commodore 64, had the lovely debugger and everything in it, and it assembled in an instant. The Commodore 64 only had a 1 MHz CPU, so if you were compiling or assembling in those days on that machine, as soon as the program got any size, you'd have to use disk assembly, and that would take 20-30 minutes every time you assembled something. So I started doing that, and assembly times got really big. I came to this system, you press a button, and almost before your finger had come off the button, it assembled again. So it was just instant. Fab. We've got Dave at the top there, that's Dave. There's Russell, if you can recognise him, and that's Gary. And the guy at the bottom is a guy called Brian Watson, who did a lot of the SD stuff. He was at that computer club as well. And we were the kind of core of DMA when we first started up. So yeah, this is my first games. So this one at the top here is Ballistics. Really bad. Okay. And then we went on to Blood Money, which was my dream Commodore 64 project. It was a shoot 'em up, I could put sprites everywhere. It got a 91 or 92% rating in Zap, which was one of the big magazines back then, which was great. The Ballistics got me into the industry, and Blood Money was the one that really backed my piece for there. And after that, I kind of moved on to do console work. We got a contract to do Shadow of the Beast on the PC Engine, and then it moved on to the CD-ROM version of it. PC Engine was the first device to get a CD-ROM, and when we got the device, we got a huge hard drive that was about that thick, massive, that could hold a gigantic 720 megabytes, huge. The whole office came around to look at it because we'd never seen anything that could hold that much. So while we were doing all these things, Lemmings started to appear, and it gets interesting. So Dave was finishing up Blood Money, and he'd always intended to use one of the characters in Blood Money as a game. He had in the first level he had one of these Star Wars walkers running about, and it was really nicely animated for its time. So he really wanted to do a game with that character in it, and he had a whole load of concepts that he tried out. And we had a kind of now famous argument about what we'd start. That's just a bit more money showing if you've not actually seen it before. So that was Blood Moon in the Amiga. This one is. It's just a standard shooter up. Shooter. So there's the walker out of Blood Money, and he really thought it'd be cool to have that as a controllable character by you. And he was then getting into how you could, what you would shoot in the characters and stuff. An artist that was there at the time to do artwork for this, a guy called Scott Johnson, who then went on to do Higher Guns and so on afterwards, was making the guys that were running you were going to shoot at 16 by 16 blocks, which kind of would have brought them up past the knee, pretty large. And I'd maintained you could do them much smaller. So we had this big running argument. I had a kind of inspiration from it from early Commodore 64 days. This guy up on the right here is from a game called Beachhead 2 on the Commodore 64. And on the left, you can kind of see him running about there. He's actually a bit bigger than I kind of remembered at the time, but they are beautiful animations, but you don't actually need that much detail in them to get the movement of it. And then the other game down here is a game called Oids. It was on the ST, where there were tiny little characters. And again, you got great movement out of them, so you kind of knew that they were a figure. So I kind of had a good idea at the time that you could definitely do these guys smaller than 16x16s that were quite big for the time. And this image was born. So I did the kind of blue-haired guy. I did them walking up the ladder, getting shot by the gun, the 10-ton weight, and the kind of burning down one. I then showed this to Russell, Dave, and Gary, who all fell about laughing, thinking it was hysterical, them all just getting shot. Gary then decided to add a few more, so he did the clown eating them, getting splattered and squished and all that kind of stuff. But he also did the really important job of refining the character. If you notice here, so my one's the one on the left, very stiff. The height's about right, but he's really stiff. Gary just took it and very quickly, as we said, made this other one, which is much more Lemmings-like. The animation is much smoother, you get the kind of bouncy hair and so on. And there's not much of a difference, but it gives it that flow that Lemmings was really known for. The colours were obviously a bit psychedelic at the time, but we'll get to that. So, the reason they're this colour, yeah, I know I'm saying what that is. The reason of this colour is because of the EGA colour palette on the PC. We had very limited choice. So, we decided to make them this, but we could have swapped them to have a green body and blue hair if we wanted. We just thought that looked better. We did actually use the other way about for the two-player mode, just to distinguish them. They were only drawn with a couple of bit planes on the Amiga, which meant they were very fast to draw, because we didn't have to do the full 16 colours. So just swapping the two channels around gave us a bit of variety for two players. This was the original demo, which I'm taking a look up, yeah. Which you can actually download off my site, I believe. I think I've got a little file. You'll probably have to run it in DOSBox. But it's basically these guys just fall and walk, and that's it. Russell coded this in 1989, 90-ish, 89. And we took it down to a PCW show.
I'll show you the code then.
We will. We took it down to a PCW show in 89 and showed Psygnosis, and they were really interested in it. And that kind of sparked the kind of Lemmings movement internally. That's all the animations that the Lemmings guys have. We've got walkers along the top, diggers, bashers, and so on. The walkers were quite interesting. They actually animate through a 16x16 so that we don't have to rotate them. So again, for that machine, they went on the screen a bit faster and we could draw more. The goal was to get as many as possible onto the screen. And for its time, 100 Lemmings was an awful lot of characters. These days, I did a test, it was 8 years ago now, yeah, with a modern graphics card just to see how many I could get. And I got 1 million at about 70 frames a second. So, yeah, times have moved on a little bit. Back then, 100 was good. So it's a bit close, zoomed in. These were actually animations I did for the Atari Lynx. The big ones on the panel, I did the Lynx control panel. But you can kind of see the original ones that I then smoothed out a little bit. We've got a few of them. That's the guy that climbs up the walls. That's the blocker. What we call the floater. He's rolling. Again, they were all just kind of cleaned up and made it a little bit prettier for going on this big full screen panel. Basher, and builder, so the problem with Lemmings is when they came to do all the artwork, they said, well, what does it look like? We had no idea. There were a little bunch of pixels from early days. There's no concept art or anything like that. So Gary went off and just drew what he thought a lemming looked like when he was drawing it. This is one of the original sketches that they did. And the box art came out very close to this stuff. The modern ones haven't changed that much. They're still very much like this. probably a little bit cuter, but in general they're about the same. And the big thing that made Lemmings was it had a built-in level editor. I don't know if any of you come from Amiga or know it. It had a program called DPaint, which was the art program to use. And we modeled, I said we, Dave, modeled the level editor on DPaint, and that made it incredibly versatile to use. Lemmings basically walked over whatever was in the background. So that way you could just add more and more objects to it, and they would just follow the scenery. Because of that, there was it meant you could just take these predefined brushes, put them down anywhere, and make a picture, and the Lemmings would just walk over it. We had a few different modes for it. You could put a block down, you could use it as a mask to cut away, and that let you sculpt some very interesting levels. That's actually one of mine, I think. That's the first one in Mayhem. I think it was about 512 blocks he allowed, and then because it was a bitmap that went down, the collision for the metal stuff wasn't based on that. So you were able to put down red rectangles over all the stuff that you didn't want to explode, or be taken away with explosions or dug away or whatever. So there's big red boxes around all the metal bits. And then just a quick shout out to the two-player Lemmings, which hasn't really been carried forward. The two-player Lemmings was great fun, because you'd end up sending a single guy over to try and sabotage the other side. And it got into real battles sometimes. The guy would be thinking these Lemmings are going nicely to the exit, when in fact you've just dug away at the bottom of the exit and these old Lemmings are just dying. So it was really satisfying. We were always going to do a network game for it, or over a cable modem. Never quite worked out. We just decided that 2 mice and 1 machine was the way to do it. That unfortunately meant things like the PC one just couldn't do it because they couldn't have 2 mice at the time. So when we came to do the end sequence, we'd spent all this time doing these levels, and we'd made a whole lot of hard levels that we then had to make easy because we just like making hard levels. We ended up just fighting with each other to see who could do the best level. So by the time we finished Lemmings, we were all so good at it that no matter what level somebody brought in that was near impossible, within about 10 or 15 seconds we go, yeah, you do it like that, it's fine. So we took all the hard levels, made a bunch of easy ones, and then decided how we're going to finish it. We weren't really one for end sequences, so I'd been drawing this guy from some of the promo material that Psygnosis had sent us. It was going to go in the shop. And so Dave came up with the bright idea of digitizing us badly and putting us around it. And then I seem to remember we cheered in the background. Yes. That was it. And that was your end for finishing all these levels. It wasn't, yeah. So what I'll do now is I'll let Russell do his bit of Lemmings, which is the PC side. And then I'll come back and do just a little bit after that.
There you go. Mike's already stolen a whole lot of my thunder. So, yeah, 20 years ago, yes, that's me again. Yes, young me. I don't know. Yes, and that is the bedroom. Yes, that's what Mike's talking about. That's the desk bit there, and you can see the chest of drawers that we shoved a plank of wood in, basically, to form another desk. So yes, I started out about the same time as Mike. I started out in Spectrums. So I did a lot of Z80. Dave Jones and I started off converting games. Dave Jones actually used to work in the Timex factory in Dundee. That's why there's so many games companies in Dundee. There's a Timex factory there, and that's where they actually made Spectrums. So a Spectrum used to fall off the back of a lorry quite frequently within Dundee. So there was lots of them, and lots of kids got access fairly readily to Spectrums. But when I joined DMA, we weren't wanting to concentrate on Spectrum games back then. No, the next big thing, the next generation, as we like to talk about, was all Amiga and ST and PC back then. Which, believe it or not, there was hardly any around. There was hardly any PCs in the UK. PCs were really an American thing. And so I drew the short straw, and I got to do all the PC side of things, which suited me down to the ground because I like Z80, And the chip that was in PCs back then, called the 8086, was actually a Z80 variant. It's actually the other way around. Z80 is part of 8086, but it was very familiar to me. So I did all the PC side of things. Here's an 8086 chip from Intel, 1978. And just coming out were machines based on this chip, which was the 286. Now, what you got to remember back then is we were writing in machine code. We don't have the help of compilers back then. We were actually writing directly, it's kind of at the assembly language level, and I'm going to show you some of that later on. We actually really only had these things to play with. Didn't have anything called variables. We had to use registers, and how they interacted and what you actually did, and what you could do dictated how we could make games. Another thing was we didn't have Windows back then. We were using DOS. And along with that came all sorts of problems and issues and things that you just don't have to think about these days, which is good, I can tell you that. We also had to handle the fact that somebody had decided that 600, who would need more than 640k of memory? Okay, because that's all we could actually address. Okay, so it was actually getting more memory, getting up to a meg of memory was an amazing achievement. It's kind of back then you were constantly having to fight with mouse device drivers and VGA drivers and all sorts of things to actually fit your game into memory. So as Mike said, we came from Spectrums and Amstrads. That's what that thing across there at the corner is. Commodore 64s and even exotic things like Dragon 32s was what we were used to. And we were moving into this world with Amigas, Nestes, and the ability to draw lovely balls like that. So Mike was already showing you the animation. This was the initial impetus for doing Lemmings. I can remember when Mike showed us it, and we all kind of looked at each other and went, there's a game in that. There most definitely is a game there. And it became a little bit of a challenge within the office because we only thought there was a game there if we could actually show that many characters wandering around the screen, if we could show that they could follow the terrain and the landscape and be able to do these things. So the main problem for us was the number of characters on the screen. We knew we wanted to have a lot. It was going to be useless if you could only have 8 or 9 or 10 or something like that. The whole idea wasn't really going to work. And they had to follow the terrain, which meant that they would have to process what was going on and how were they going to follow that terrain and how were they going to fall and do all the different things that we wanted to be able to do. Part of our inspiration here was, I don't know if you'd ever played a game called Nemesis or Salamander. They were shoot 'em ups in the arcade back then, and this is a particularly bad picture. It was the only one I could find. But they had bullets, you can see here. And the thing about the bullets was they actually followed the terrain. It was quite rough, but no, so we knew you could do it. We knew it could be done, we just had to work out how. And eventually, I had a sort of flash of inspiration. It was one of those moments where you're in the shower and you, there you go. I can't remember if it was in the shower or if I woke up and just went, right, I know exactly how you can do it. So this is the pseudocode, basically, for it. So you're moving in the X direction, you move forward 1 pixel. Then you check all the pixels above. If there's less than 7 set above you, right, move up the way. So if it's between 1 and 7 pixels up the way, move up. If it's greater than that, you've hit a wall. Then, if you've not hit the wall, check the pixels below you. If it's less than 4, then you can move down the way. If it's greater than if it's greater than 4, then fall. And it was that simple. It's just that little bit of inspiration just on that's how it all works. And it all hinges around, here we go, this is actual assembler. This is the actual routine in Lemmings that actually moves a walker around. If you want, you can come and examine it more closely later on. I'm not going to bore you too much with the actual details, but you can see it's checking, it gets the pixel in collision here. It's then checking up, but it checks up the way. It does say down, but that's just because I'm thinking differently from everybody else. And it checks up, but it's actually checking down, and then it does all that stuff here. And after Lemmings, I didn't just write Lemmings once, of course. I ended up writing it about 15 different times on different platforms. This is the C++ version of exactly the same code, so you can examine that if you want as well. That was for Lemmings for Windows that we did that for. So the other key factor of that was once we got how to actually move things around, key factor here was how are we going to render that many of them? Because back then there was no such things as GPUs. There was no such things as fast blitters within the PC world, which existed on the ST and on the Amiga. It was all to do with the processor and how you actually did that, and the way you actually address things on the PC to write to the actual screen was quite arcane. Okay, actually, if you look at back on how pixel shaders started, this was how pixel shaders started, because the VGA latches, which is how you write to its kind of memory, were basically what pixel shaders started off being, allowing you to program properly. Up till then, we had to just write to registers in memory, and you had to understand exactly what the hardware was doing behind the scenes. And that's the reason why they have green hair and they're white and blue, because those were the colors that I could use on a PC EGA device, and those were the only colors that were available to us. So that's why Lemmings are the way they are. And we were able to get 100 on screen on a normal 286 machine running at about 4 megahertz. Yes, that's 4 megahertz, not gigahertz or anything like that. It was at 4 megahertz, because that was standard PC back then. As Mike said, I was actually still at university while I was doing all this, so I ended up, after I'd done the demo, putting things on hold because I was going to do Lemmings when I got back from my exams. So I got my exams. That's not actually a picture of me doing it, that's just a picture of an exam. Now, the complication on the PC side of things, when I actually got back to DMA, to the office that Mike showed you, I actually discovered that Dave had decided to ditch the game he was going to do, and he'd already started Lemmings. Because I was actually going to start it on the Amiga, but that's all right, I'll get going on the PC version. What I actually found out was the PC version wasn't just one version. The PC was actually 4 different versions, because we had to do EGA, VGA, Tandy, and CGA. Okay, and it wasn't just for one type of machine, you actually had to cover all these different types of PCs, speeds of processors, all sorts of things. The PC world was a bit of a nightmare. If you think of Android just now, with about 1 million different devices, with 1 million different processor speeds and 1 million different GPUs, that's pretty much PC world was back then. The other problem with PCs, of course, is that somebody could put all these different cards in, and that they could actually handle all sorts of different joysticks and things like that. And things weren't as ubiquitous as they now are. Now, networking, nobody had a network card and things like that in the machine. You might have a serial port, not all machines had serial ports. Some might have had parallel ports and things like that. So there was ways of talking to machines, but they weren't really standardized back then. So when 2-player Lemmings, we loved 2-player Lemmings. But the problem with 2-player Lemmings was, on an Amiga, you had 2 ports that you could plug a mouse into. And there was no such thing as a mouse driver. You could just read the actual mice directly from that particular port. But on a PC, I had to do all my reading through the serial port. Well, no, actually, I didn't, because you couldn't access the serial port directly. You had to actually read it through the mouse driver. And the mouse driver had no concept of 2 mice being plugged in. So I just could not do 2-player Lemmings, unfortunately, which was a big disappointment because I loved it. And I had most of the other code written, it was just I couldn't read 2 mice. So yeah, that's a particularly badly cut out picture of a floppy disk. We also had to do it on 2 different media, because they had 1.44 floppies, but also back then 720K floppies were the actual standard. 1.44 was this new fangled format. So I had to squeeze all the levels of Lemmings onto a 720K floppy and handle the installation process. And also the QA side, because we had all these PCs. Lemmings came out in the Amiga and ST on the 14th of February in 1991. Thank you, Mike, for correcting me. 1991, and that was on the Amiga and the ST. We were actually finished the PC version by then, but there were so many different things that had to be tested on. It was actually delayed for a couple of months while we tested it on every flavour of PC that we could underneath the sun, which gave me a lifelong appreciation for QA and the work that QA actually do. And I would really impress upon you that QA do a really valuable job just in terms of making sure that the user experience is correct across the multiple devices and platforms there. The other thing that we had to contend with was various bugs. We had all sorts of funny things going on. Because the PCs are so various, there was things that you took for granted on other platforms. There was timing issues which only cropped up on particular PCs when you actually got to particular levels. There was bugs with device drivers that we had to work around that had to actually it's going to change the way in which the actual code worked. So there was all sorts of things that the other platforms really didn't have to contend with. We then went on to do Oh No More Lemmings, and then Lemmings 2, The Tribes, as well on various platforms. And I left DMA Design after doing Lemmings 2, The Tribes, although we still worked together on various things. We did Windows Lemmings, and my company, Visual Science, also went on to do a game called Lemmings Paintball, which had was really one of the first cross-platform networked games using TCP/IP and NetBIOS and various other ISP protocols. Worked on Macs and the first PlayStation as well. There. So anyway, there we go. That's the end of my talk there, and I'll hand back to Mike for his last little bit.
Okay, so that was Lemmings. After Lemmings, aside from doing a million other versions of Lemmings, DMA did a stack of other games. Shadow Beast at the top there, Lemmings 2, Hired Guns. That one there's a Kid Kirby game that Nintendo commissioned us to do that got canned. We did Euro Racers, Holiday Lemmings, I think it was called.
Yes.
Lemmings 3, which was awful. Walker, which finally came out, which was the whole inspiration for this, but years later. Then Atari Lynx Lemmings. We also did a Philips CDI Lemmings, ZX Spectrum Lemmings, and Shadow the Beast on the Commodore 64. So this kind of took us up to about 93, 94 time. We did quite a lot in the early years. After that time, I kind of went into doing R&D in the company, and basically got to play with whatever I wanted to, which was fine. Out of that came a few different things, one of which was a 3D engine that the company used later on. We had an engine called 3DMA, which had software rendering and hardware rendering, and the games guys could just import models and draw stuff, and we'd take care of everything else. The other thing I was playing with was an isometric idea. So I'd never done isometric games in kind of all seriousness before. So I sat down to plan out, what do you need to do for an isometric game? So I kind of drew this and went, yeah, okay, there's a path through. You'd have to draw it, the very back corner down the far edge, and then just keep drawing in front of stuff. And then you could draw characters as you go with those as well. Isometric games also used to like to rotate the view. So you basically pick a different corner and draw backwards or sideways with different assets, and you could kind of rotate the view around. And that was easy enough. But I thought, well, what about rotating it? So it's a nice smooth rotation. I've been playing with texture mapping stuff. So I thought, well, how about if I texture mapped each of these cubes and then somehow rotated it, with somehow being a bit of a mystery at the time. I'm not very good at maths. In fact, I'm crap at maths. So everything I do is basically a cheat. And true to form, I decided to cheat on this. And basically, I create an ellipse on the ground, which is fairly simple. It doesn't take a lot of math to do that. I can cope with that. And then I put each corner on the ellipse, and then I move them around. So that gives me 4 points moving in a kind of rotation, so they can move. I then draw lines from each of these points, making a nice kind of base of that square kind of going around. From that, I can then draw or plot points evenly down each of these lines, and then across the screen to the other side. That gives me a grid of points rotating around this ellipse. Still not exactly hard math so far. And from there, I can then project straight upwards, decrementing a y-coordinate. I can do that as well, that's fine. From that point, I then have this world of cubes that's rotating nicely. And that led to this, which was the first kind of prototype that I kind of showed Dave. Now this world, based on an isometric thing, was sitting on this ellipse, and it could rotate. And by changing the angle and the size of the ellipse, I could tilt the view a bit. It's still made out of cubes, so each face there, each little window and block was one of these cubes. Texture mapped the side using a very fast vertical texture mapping algorithm that Doom used. The top was done using a very cheating texture mapping routine that was very fast. And you could just spin it very, very quickly. It was written for a 486 machine, ran in frame, and I had blocks moving up and down kind of smoothly in it, which was kind of a requirement for doing anything with it. There's also in the background, you can kind of see a road going up the way. That was a slope. That's basically taking from one side of the cube to the other, kind of slope going up the way. So showed Dave this. There's also streetlights down there that acted as objects in the world that kind of moved with it to prove that concept. So like I said, showed Dave this. He was like, oh, very interesting. So he passed it off to one of the games teams to kind of go and, this was all written in Pascal and assembler, back when Pascal was good. And basically you could just put inline assembler in that, and most of it was actually in assembler. Pascal just let me do the higher end stuff easily. So the games teams took this and started to rewrite it and try and do high-res version of it and all that kind of stuff. But they were struggling with performance with it. At about the same time, a game called Syndicate Wars came out, which is kind of a rotating isometric thing. And all of a sudden you looked at it and went, yeah, that's not a very good game, is it? So fortunately, we canned that one. It was along a very similar lines to that, would have varied a little bit, but it was too close for us to really ignore. Fortunately, while the games teams were struggling with this other idea, I was playing with this one. Now, using the same idea, basically creating an array of points and then drawing stuff between them, I decided just to change my viewpoint and do a bit of perspective straight down. Still no real maths in it, it's just an array of points with a perspective calculation. Still very easy. And then I just pan about. And that was the original GTA demo that I then showed the other guys. It's got an advantage of you've got a very fixed view, meaning you could have a very complex city if you want, because you could cull out everything off screen. You got nice smooth movement of everything. Again, this was written for a 486 machine. Now 486, again, you had no GPU in it. There was no cache to speak of in it. It was basically execute as few lines of code as possible to make it go fast. So the drawing for this, for doing the spans and doing all the scaling, was actually a meg of raw code built up with macros. And what I would do is I would decide how many pixels I had to draw, then jump halfway into this code to execute that number of draw calls, stored routines effectively for the CPU. And that let me draw things, again, very quickly for a 486 machine. And this ran kind of in a frame as well. So there was two requirements before this was handed over to the game team. One, what does a car look like in it? So we added a car. The second one is, can you do slopes? Now, I'm not quite sure where the slopes is in this. I think it's around on the side of the building. But again, the same idea as before. You'd basically take the bottom corner of a cube, top corner, and then you draw a slope between it. So that's why GTA's roads are very angular, because it's just going between two of these kind of corners of a cube. There was a problem when we came to actually put it into the engine, and that's how you draw this without getting any overlap, because we had no Z buffer. So the problem with getting this in and moving correctly all the time is you want to make sure that there's no building hiding a part of another building. So I came up with a very complicated way of basically doing a spiral around the whole level as it goes down, drawing the outer edges coming in so that the last piece just slots in, and you can do it that way. Fortunately, I didn't have to write that, so I just told them how to do it. That was fun. But that's how GTA does its rendering. And it's basically this engine rewritten in C++, taking over again. I did go back in later on once they'd done this, and I changed all the C++ rendering into assembler. By that time, Pentiums were out. I did full optimization at assembler level. Pentiums have a dual pipeline, so you could optimize better and get multiple instructions being executed at once. So you had a few other bits coming in at that point. We also did a 3D effects version, which ended up being the best version of GTA. 3D effects had given us a couple of cards like a year earlier, and then all of a sudden they were coming to visit, and we had nothing to show for it. So I was like, what can we do quick? Well, because I'd written the library that the games team were using, I was able to just take that library, make a quick version of it in a few days, and then GTA was running. It turned out so well that we decided to ship with it, and BMG never paid for it because it wasn't scheduled. We just liked it too much to throw away. So the 3D effects version came about because we felt guilty. So the other interesting part of GTA, aside from all the kind of gameplay stuff that went into it, was it originally looked like this, which was very kind of classical for the 95, 96 kind of time frame. It's all very grey and boring because you were using 256 color mode. So you had a fixed palette and that was it. Around that time I was speaking on the kind of internet news groups, which don't really get used very much these days. And I happened to comment on there that it'd be really cool if we could use some of the high color stuff but at low res, because the throughput wouldn't matter too much if you're a nice low resolution. Coincidentally, there was a company called SciTech who did a program that let you do all these super VGA modes and so on. And one of the guys was on the forum and said, we've got a new version coming out. Oh, lovely. So he gave me a test version, and I started playing about with it, and I could get a 320-200 stream at 16 or 32-bit mode. And it turned out that writing 32-bit per pixel was exactly the same speed as writing 8-bit per pixel, because it was the proper word size for the CPU. So that was born. And it was basically the same tech, a different library. That's why there's a couple of different versions. And the problem with this is they had to go and redo all the art. Sorry. But it was too good to give up. The art had pretty much been done for all the grey ones, but they then spent another year redoing all this, so it was delayed quite a bit. Every graphic has its own palette, so it's basically still a 256 color tile, but we kind of do an indirect into a user palette, so we can then render 32-bit. That keeps the size of the whole file down, because storing full 32-bit graphics was quite large. But it meant the artists could kind of go to town on tiles and then come up with different color palettes, depending on the building type or whatever. Coincidentally, about this time, we got a visit from Tim Sweeney. He was doing Unreal 1 at the point. It wasn't out yet, I don't think, or not quite. And we told him how to do this, which is why Unreal has, or the original Unreal had high color stuff, because he pinched it from us. We did show this at one of the shows, and we had a whole load of programmers around asking how to do it, because it was just so different from everything else. We also had the SimCity guys appeared at the booth as well, asking about it. They just released, I think it's Streets of SimCity, which was basically their 3D version of driving around one of your cities. But we're really interested in this. Didn't go any further, but Dave was inviting them to come and talk to us about it, because we could obviously have a huge city, and the SimCity stuff would have fitted really well in it. And that's it. So if you're really interested, the original Race and Chase design doc, which is what GTA started out as, it was a cops and robbers game, is on my Flickr thing. You can go read the whole thing. As we said, it's not very interesting, but it is there. And you can see how it all started and how it totally changed by the end of it. The original game, let's say, was a cops and robbers game. You're going to be one or the other, and you're going to chase around, and it just totally evolved into something else. Fortunately, BMG kind of went with us and helped. It was a bit of a battle, but we got to do it. There you go, and that's it. Thank you very much.